Have you ever felt like your computer is just actively working against you? Like you're not speaking the same language? Well, it turns out there is a hidden language, a whole set of rules that governs the relationship between you and all your devices. So today, we're going to decode that language.
Listen to this quote. It's from a famous design textbook, and it's just so painfully relatable, right? A tiny slip of the hand, and poof, your work is gone. All because the save and delete options were designed to be too close together. It's a perfect, frustrating example of how one small design choice can cause a huge problem.
And that really gets to the heart of it, doesn't it? Why does this technology that's supposed to make our lives easier so often feel like a total obstacle? Well, the answer lies in this really fascinating field of science that's all about making that conversation between us and our computers, well, less frustrating.
That science is called human-computer interaction, or HCI for short. You can think of it as managing a conversation between two very, very different brains, the human brain and the computer's processor. And to get them to work together, you first have to really understand the human side of that equation.
When you boil it all down, every single thing we do with a computer is part of a loop. We take in information with our senses, what we see on the screen, what we hear, what we feel, and then we act on it, sending commands back with our hands, our fingers, or our voice. It's this constant back and forth.
And this leads us to a really crucial idea, the mental model. It's basically your brain's internal blueprint for how you expect something to work. It's built from every app, every website, every device you've ever used. So when a new design breaks that blueprint, like putting a button in the wrong spot, it just feels confusing and weird. Great design works with your mental model, not against.
So for designers to work with our mental models, they have to understand the quirky, sometimes counterintuitive ways our brains actually see the world and remember things. And trust me, it's not always what you'd expect.
Take this for example. Your perception is not a perfect camera. Not even close. We consistently see the visual center of a page as being just a little bit higher than the true mathematical center. That's why graphic designers have a term for it, the optical center, and they'll intentionally place the most important stuff there so the design feels perfectly balanced to our eyes. It's designing for psychology, not just for a ruler.
And then there's this famous number. You might have seen it before. 7 plus or minus 2. It looks so simple, but it actually represents one of the most critical bottlenecks in the human mind, a hard limit that designers are constantly bumping up against.
It's known as Miller's Law. Basically, our short-term memory, think of it like your brain's RAM, can only juggle about 7 chunks of information at any given time. So when an app throws a menu at you with like 15 different options, it's literally overloading your mental capacity.
Okay, this is a brilliant real-world example of designing around that limit. The first ATMs used to give you your cash before giving you your card back. The problem, as soon as you got the money, your brain would go, okay, task complete, and you'd just walk away, totally forgetting your card was still in the machine. So now, modern ATMs always return your card first. It's a simple, genius change in sequence, all based on understanding how our memory works.
All right, so that's us, the humans. But what about the machine? Our computers and our phones aren't just blank slates. They have their own histories, their own physical quirks that absolutely shape how we interact with them.
Just take the QWERTY keyboard, the one you're probably looking at right now. You'd think it was designed to be fast and efficient, right? Nope. It was actually designed to slow typists down to stop the metal arms on old typewriters from jamming into each other. There's a much more efficient layout called DevoRack, which puts 70% of the most common letters right on the home row. So why are we all still stuck using QWERTY?
Well, the answer is something called technological inertia. We are just so deeply invested in the old way of doing things with billions of keyboards and millions of people who already know how to type on them that the cost and effort of switching to something better is just too high. We are literally using a tool that was designed for a world that doesn't exist anymore.
So you've got the quirky human brain on one side, and the machine, stuck with its own history, on the other. HCI tries to build a solid bridge between them, and that bridge is built with almost mathematical precision, right down to the actual science behind a single click of your mouse.
This right here is Fitts' law, and it's one of the cornerstones of interaction design. It's really just a formula that can predict how long it'll take you to move your cursor to something on the screen. And the logic is super simple and powerful. The bigger a target is, and the closer it is to you, the faster you can click it. It's why that tiny little X to close a pop-up ad is so infuriating. It is intentionally designed to be small and far away, to be hard to hit.
And this isn't just a theory. You can see it plain as day in the data.
Look at how long it takes to do the same task using different methods. Double-clicking a big, easy-to-see icon? Less than 2 seconds. But navigating through a tiny menu to find the same command? Over 4.5 seconds. That menu item is a smaller, more distant target, and the time penalty is real and measurable.
So, when you put it all together, when you combine an understanding of our human psychology with these physical laws of interaction, that's when you can finally start to create designs that actually speak our language, designs that make technology feel a whole lot more human.
So what should you really take away from all this? First, that good design understands we're human, and we have limits, like our forgetful short-term memory. Second, the absolute best interface is the one you don't even notice. It just feels invisible and gets out of your way. Third, great design is just as much about psychology as it is about code. And finally, every single choice matters, from the size of a button to the order an ATM gives you your stuff.
And that leaves us with one last massive question for the future. As computers continue to shrink, as they move off our desks and literally disappear into our walls, our clothes, and even our bodies, how are we going to make sure that this secret language between us and them remains a clear, productive, and ultimately a human conversation?